Hello everyone, in this video I will explain the concepts of area and circumference of a circle. So first thing we know that a circle is a shape which has a fixed point in the middle. So we call the fixed point the center of the circle. And then we have a fixed length which is called the radius of the circle. So you start with a fixed point and then you have a fixed length whose name which is called r, and then keeping this fixed point, so you rotate this fixed length, and circle is the locus of all the points that this line gonna make. Therefore, we can draw the different lines here. So these are all radius. So this is a radii, this is a radii. So we call these as radius of the circle. So r is radius of circle. If we keep extending r and we make a line that is passing through the center of the circle, so that big line would be called the diameter of the circle. In other words, the diameter is double the radius of the circle. So it's very important. So diameter is the line that passes through the center of the circles and touches at the circumference of the circle at 2 points. Next, we discuss the circumference of the circle. So circumference of the circle is the length of the boundary of the circle. So it's equivalent to when we talk about the polygons, we talked about the perimeter. So it's essentially the perimeter of the circle, and it has a special name which is called circumference. So circumference is the length of the boundary all around the circle. When we talk about area, we talk about the space covered by, this is called the area. So area is the shaded area that's covered inside the circle. The circumference of the circle is calculated by 2 pi r. So where pi is just a constant whose value is 3.14159 and r is the radius of the circle. So I would recommend when you do the problems, do not use the rounded off value of pi. Instead, use the pi button on your calculator so that you don't get a rounding off error. The first formula is 2 pi r. So I can just rewrite this as pi times 2r. And we know that twice of radius is the diameter, and we get our second formula. So you can use any of these two forms in your problems. They are the same thing. Similarly, area of a circle is also dependent on the value of the radius. So it's given by pi r square. So in this case, again, we have two forms of the formula. So you can just plug in the value of r here. So r is half of the diameter. And when you solve it, you get pi d square over 4. So which is here. So essentially, they are the same formula. So one mistake that students usually make is they mix up the formula for circumference and area. So I always recommend that you look at the units. For circumference, which is just the length, you're going to have the units of length. So it means the formula should contain only 1 r. But for area, you're going to have the units, square units. So the formula should contain r square. So that is how you can link this with the units and avoid making mistakes. Alright, so let's try some problems where we will calculate the area and circumference. So first one is a simple problem. So we are given a circle of radius 16 and we need to find area and circumference. So we just learned that area is given by pi r square, and in this case r is given 16 centimeters, so area would be pi times 16 square. So you can plug in the values in your calculator and you find that, so pi times 256, which is approximately 804.25, and square units will be the units for this calculation. Similarly, the circumference can be found. Circumference is equal to 2 pi r. So 2 pi times r. So we get 32 pi, which is approximately equals to 100.53, and the units gonna be the linear units only, centimeter. Moving on to the next problem. So we are given the area of the circle is 156 square meters, and find the radius. So we are given this area. Area is equal to 576 square meters, and our goal is to find the radius of this circle. Since we know that area is pi r square for a circle, so this implies pi r square is equal to 576, and from here r square is equal to 576 over pi. But we are interested in the value of r, so we have to take square root on both sides. So r would be square root of 576 over pi. So using the calculator, you will find that the radius is approximately 13.54 meters in this problem. Let's take a look at the next example. So in this one, we are given a pipe whose outside diameter and inside diameter are given. We need to find the area of cross section. The cross section will look something like this. So we have to figure out the area of cross section, and we are given the diameters for the outer circle and the inner circle. So in this case, in order to find the highlighted area, we can find the area of big circle, and we can subtract the area of small circle out of the area of big circle. I'm going to name the diameter of bigger circle as capital D, which is given 3.50 inches, and the corresponding radius would be 3.50 over 2, which is 1.75. And also we notice that the diameter for the smaller circle is 3.25 inches, and the corresponding radius would be 3.25 divided by 2, which is 1.625 inches. Let's use these values of radii in our formula. So for big circle, we get pi capital R square, and for smaller circle, the area would be pi small r square. Putting the values in, a times 1.75 square minus, pi times 1.75 square minus pi times 1.625 square. So in the using the calculator, you will get approximately 1.325 square inches. So that is our required area of this cross section. So always analyze the problem and see what is given and what it is asking you to calculate. Next, we'll try some more problems. In this problem, we need to find the length of the strapping needed for the pipe. So we need to find this length of the strapping, the black one, which I just highlighted. So in order to find that, we will figure out the different parts. I'm just going to make some divisions of this strapping. We're going to figure out the different divisions and just going to add them together. I have given some names here to different points. So A, B, C, D, E, and F. So the total length of strapping, so if we look at the bigger picture, total length of the strapping would be sum of all these small parts. So we can add AB and then we can add BC and then we can add CD and then we can add DE and EF. By looking at the given shape, we'll notice that AB is already given 1.50 inches. And for BC, we can find this using the information about the diameter of the pipe. So this is same as the radius of the pipe. So BC would be half of diameter, which is just 6. So I'm going to write 6 here because it's half of the diameter. Next, we're going to find CD, which is the arc, which is this arc, right? So this is essentially the quarter of the circumference of the circle. So CD would be 1/4 of circumference. So we get pi r over 2, and r in this case is the radius. So radius is given to be 6. So pi 6 over 2. So we get 3 pi as our length of arc CD. So next we have DE. So DE is this length, which is same as the radius of the circle. Again, this is 6. And in the end, we have EF, which is already given in the diagram. So EF is 1.50. Thus, adding all these numbers together, we get the length of strapping is 24.425 inches. And this is what we were interested in finding. Let's practice with one more problem. So take a moment to read this problem carefully and then I will discuss it. So you can pause the video while you read the problem. In this problem, we got a shaded area which is formed by removing 4 quarter circles from a square with sides of length 25. So we are given a square whose side is 25 centimeters, and you can visualize this as, so you have 4 circles on this here, and part of the circles are removed, and then we get this middle area. And then out of the middle area, they removed a biggest possible circle, and then they got this shaded area, which is the gray area. So our goal is to find the area of the shaded figure. So we have to find this gray shaded area in this problem. Let's take a look at the bigger picture here. So if we are interested in finding the shaded area, so that can be given by area of shaded region is equal to area of the big square. So area of the square minus, so we have areas of 4 quarters of circles. So minus 4 times, so area of circle 4 quarters. So that will make 1 full circle. So essentially we have area of a full circle. And then minus the area of middle circle. Let's say the area of middle circle is given by, the radius of middle circle is given by small r. So r is the radius of middle circle. And similarly, for bigger circle, we can use r, capital R as the radius. So rewriting this whole thing, we get area of the square would be side square, in this case 25 times 25, and area of the circle with radius r would be pi r square minus area of this middle circle would be pi small r square. Now we already know the value of capital R, but we do not know the value of small r. So our side goal is to find, so first we're going to find small r, which is the radius of middle circle. So here, so r is the radius of middle circle. So this is 1r. This is 1r. So I'm going to complete this diagonal line and see what I get. So completing the diagonal, so we see that this is made of, so two small r's, and then we have, so this is the radius of bigger circle, and also this is the radius of bigger circle. I'm going to name this as A, B, C, D. So essentially, we can say that AC is made of 2R plus R plus R plus R. So AC is made of two capital R's and two small r's, and capital R is 12.5, small r is what we need, and AC we can find using the Pythagoras theorem. So we have 25 on this side, 25 on this side. So this is our hypotenuse. So AC would be, using Pythagoras theorem, square root of 25 square plus 25 square. So AC is approximately 35.355 centimeter. So we're going to use that value here. So AC is 35.355. From here, 35.355 is equal to 25 plus 2r, and from here r would be 2r is equal to 35.355 minus 25. So r is half of that. So after solving, we get r is 5.1775. So now we have the value of capital R, small r. We can plug in the values and we can get the desired result. So 625 minus pi times capital R minus pi times small r. So I just put all the values in, and then using the calculator, we find that area is 49.91 square centimeters. So you can always analyze the problem. Sometimes we use more than one concept in the same problem. So it's very important that you analyze the problem carefully. I hope you enjoyed this video. Thanks for watching. Please do subscribe my channel for the future videos.